Welcome back. So we've talked about what a graph is generally, some nodes with connections between them. Now let's talk about some particular types of graphs. First of all, there's some terminology. These are the basic terms we have to talk about. A vertex and edge. So a vertex is the fancy term for a node. So in a graph, when we say vertex, it's just on our diagram, one of the circles. An edge is the connection between the nodes. Then there are two pieces we'll come back to, weighted/unweighted and directed/undirected. But first, let's look at this graph. On this graph, any of those circles are vertices. This is a vertex, C. This is a vertex, B. So I might use node and vertex interchangeably, but the technical term, like on Wikipedia, you'll see vertex. Although it does say node as well in the introduction, vertex is like the technical term. And then these connections are edges. So this is an edge from A to E. This is an edge from A to B, from B to D, and so on. So from one vertex to another, that's what an edge is. So there are many, many types of graphs, different distinctions and sort of how they're built and rules they follow, just like with trees. And I actually already hinted at this. A tree, if we actually click on the page for a tree, the definition is that it's a graph in which any two vertices are connected by exactly one path, meaning that to go from 6 to 2, for example, there's only one path to get there. To go from 3 to 5, there's one path. Contrast that with some of our graphs here. To go from E to D, we could go here, here to here, or we could go here to A to B to F to D. And this is not even a great example. Some of the other ones we've seen, there are way more edges, way more connections. So for a tree to be a tree, it's just a bunch of nodes with a bunch of connections. So it's a graph. However, there's only one path from a given node to another. Okay, now let's talk about directed versus undirected graphs. So this has to do with the edges, the connections between the vertices. So in an undirected graph, there is no direction to, or polarity, you could say, to the edges. So they are two-way connections, is another way of thinking about it. A and B are a connection. So is B to A. If we're traversing this, we could go this way, but we could also go this way. There is no direction associated with an edge. And that's useful, oftentimes, depends on what you're modeling. But let's talk about like Facebook, how Facebook models friends. If you don't have a Facebook account, you probably know how it works. You have to request someone, and then they will accept your request or reject it, but hopefully accept it, unless you're a stalker or something. In that case, you are both friends. So you see that friend stuff on your webpage or on your homepage. They see your content. It's not a one-way relationship. So this is an example of what a couple of friends could look like on Facebook, where if Maria and Tim are connected, that means Maria sees Tim's content and Tim sees Maria's content. Now let's contrast that with a directed graph. So a directed graph is often represented with arrows, which indicates the direction, the polarity of that edge. So for example, from B, we can go to C, we could traverse to E, we could traverse to A. From E, we cannot traverse to B, we cannot traverse to D, or to F. So E is sort of like a dead end here. So on a directed graph, there is a direction assigned to the edge, the connection between vertices, two vertices. Yeah. So that's how you would model a social network like Instagram or Twitter, where our friendships or the following relationship is not a two-way thing by default. For example, on this chart, let's say it's Instagram, we have Maria who follows Tim, and Tim also follows Maria, so they see each other's content. But Maria follows Justin Bieber, so she sees his content. Justin Bieber does not follow Maria back, much to her chagrin. That would really make her day if Justin Bieber would follow her, but he doesn't. Same thing with Tim. Tim follows Justin Bieber. Justin Bieber does not follow Tim. But if we look over here, Justin Bieber does follow Kanye, and Kanye follows Justin Bieber. So you can see this sort of information in a social network like Instagram is important, because if you are a celebrity, you probably don't want to just see every single person's content who follows you. You want to be able to pick and choose what you see. Unlike on Facebook, where we modeled it with an undirected graph, because all connections are two-way. Although that does ignore the whole Facebook celebrity pages where you can create a special marketing account. But if we're just talking about the basic typical user account on Facebook versus Instagram, This is how we'd model Instagram with a directed graph. Facebook is an undirected graph. Okay, so there's one other piece of terminology, which is a weighted graph versus unweighted. So right now, this graph is actually unweighted because each connection between the vertices, the nodes, each edge has no value associated with it. But now, if I hit this, there we go, magically, it is a weighted graph. So when we assign a value to the edges, it becomes a weighted graph. There is information about the connection itself. So unweighted versus weighted. Everything we've seen so far has been an unweighted graph. This is an unweighted directed graph. This is an unweighted undirected graph. And this is a weighted but undirected graph. So for example, if we're talking about maps, here's our same Google Maps example in Guatemala. I'll get rid of the map. Let's say these are all cities or, I don't know, gas stations or any sort of points of interest. There's connections, there's edges between them, but they are weighted. We need to know these values. So if we're trying to calculate the shortest path, we can add these. It's not to scale, by the way. I just picked random numbers, but we would add up. If we're trying to go from here to here, we could add 40 plus 20 plus 3, or add 13 plus 120, and figure out which is shortest. Now, this currently, the way it's displayed, is an undirected graph. It's two-way connections. But maybe some of these roads are actually one-way roads, in which case, like if we were really modeling Google Maps, we would have a directed and weighted graph where certain roads, like in San Francisco or Manhattan, for example, but really all over the world, are one-way roads. You can't just go any sort of way that you want. You have to follow the rules, and there is an actual value assigned to those edges. So if we go back to something like Instagram, this could easily be represented as a weighted graph, because you might, like if you're a marketer, if we're talking about Instagram's like advertising team internally, they care about these relationships, not just who follows who, but also what their appetite is for that person's content, if that makes sense. So there would be some sort of value assigned to this relationship, or more than one value, so that Maria's connection to Justin Bieber might be super strong because she loves Justin Bieber, but Joan's maybe isn't as strong. And you could easily store that using a graph data structure. Keep track of, how many times this person did X or Y, or assign a value for how much they love a certain person they follow. So just because I'm displaying this part just to explain what a directed graph is, I'm not saying that it couldn't be a weighted graph. All right, so let's wrap up the terminology. Let's go back here. We have undirected graphs. That's what I first showed you in the last video. There is two-way connections, or you could say that there is no direction to the connections, the edges between the vertices. And even before that, we talked about the term edge is the connection between two nodes, which technically each node is called a vertex. So then there's a directed graph where there is a direction assigned to an edge. An edge could be bidirectional, like it could point both ways, but it also could point one way. Then we talked about unweighted versus weighted. So an unweighted graph has no value associated, no magnitude with each edge. A weighted graph does have a value associated with an edge. And so when we're traversing or when we're computing the shortest path, for example, we would use these values. All right, I know that was a lot. Next, we're going to talk about different ways, different strategies for actually storing the information in a graph. How do we model it? That's next.